Today we're going to be solving exponential equations, and for our first type of problem, our equations are going to have the same base. And if you remember, the base is the larger number down here. It's not the exponent. So in order to solve these problems, you have to first set the exponents equal to each other. So the exponents, which are up here, are going to make an equation. So we're going to have 2x minus 1 equals 9. And then that is an equation that we must solve. And once we solve it, we'll find the value of x that makes this equation true. So to do this, we're going to have to add 1 to both sides. And that will give us 2x equals 10. Okay, and then hopefully you guys all know how to solve this. Last step is to divide by 2. And 10 divided by 2 is 5. So our value of x equals 5. And if you did want to plug this in just to check your work, you would plug it in here. So 2 times 5 is 10, minus 1 is 9. So 4 to the 9th equals 4 to the 9th, which we know must be true. Alright, so in this example, we're going to be solving equations with different bases. So if you notice, we have a 2 on this side, and the base on this side is 8. So the first thing we're going to want to do is to create the same base. Okay, we cannot set the exponents equal to each other until the bases are exactly the same. So what you want to ask yourself, is there any way you can rewrite 8 using a 2? Okay, so hopefully you guys remember that 2 cubed equals 8. So this 8 here can be rewritten as 2 cubed. And if you don't remember that, you can use your tables from yesterday. Okay, so now that our bases are both 2's, we can set the exponents equal to each other. Okay, so again, we're going to take 4x plus 3 and it's going to have to equal 3. Okay, so you subtract 3 from both sides, you're going to get 4x equals 0. Divide both sides by 4 and x equals 0. And that is your answer. And sometimes you're going to have to change both the bases. So if you look at this example here, 4 to what power equals 8? Well, there is no way to get 8 using a 4 with an exponent. Okay, we know 4 to the first power is 1, 4 squared is 16, we've already surpassed the 8. So what we want to do is use a smaller number and change both the 4 and the 8. So if you look at your table, there's only one row that has both a 4 and an 8, and that is using a 2. So if we change 4 to 2 squared, okay, and 8 to 2 cubed, okay, we will have an equation with equal bases. Okay, we still want to keep this 6x here, as well as the 3x plus 1 on this side. Okay. So again, we now have equal bases. We have the 2's. Here, right now this looks a little messy, and we have to deal with double exponents here. So what you're going to want to do is distribute. So you're going to distribute both those with the 3 and then the 6x with the 2. So we're going to get 2 times 6x is 12x. So we have 2 to the 12x. And this equals 2. 3 times 3x is 9x. And we have 3 times 1 also. So that's a plus 3. Okay, so now that our bases are the same, they're both 2's, we can now go ahead and set the exponents equal to each other. So we take 12x and set it equal to 9x plus 3. Okay, and then we can go ahead and solve this. So we have x's on both sides of the equation, so we're going to want to move them to one side. So in this problem we are subtracting 9x. And that's going to give you 3x equals 3. Divide by 3, and in this problem x equals 1.